Hello everybody, this is Dr. Fu again. This week we're going to take a look at the module 5B, which is the CNS control in cockroaches part 2. And in this week, we're going to design experiment to decide if the circle stimulus information travels in the nerve cord bilaterally, ipsilaterally, or contralaterally towards the thoracic. Okay, so before we start to talk the experiment, we need to talk a little bit more about the dissecting microscope. The dissecting microscope is a little bit different from the light microscope because this microscope will give you the depth of your objectives. In this microscope, you have two eyepieces, but different than the light microscope. These two eyepieces gave you a slightly different lookings. That's the same way how the 3D movie works. If you go to 3D movie theater and if you close one eye, you're gonna see different thing from the other eye. So here's the light path. The image you see from this eyepieces is from this angle, and the other eyepieces is from this angle. So that way you will know if your cockroach is here and your forceps is here, you know how far that is from the cockroaches. For light microscope, the two eyepieces sees exactly the same images. They are not slightly different. They are exactly the same. That's why you cannot use a light microscope to do that microsurgery. So the goal of this experiment is to decide how the circle information travels ascendingly. So there are three routes. They can travel either ipsilaterally, which means the signal will travel the same side on the nerve cord to reach the thoracic region, or contralaterally, which means cross the ganglion and reach the other side. So for this model, between A4 and A5, the signal actually travels ipsilaterally. And then after A4, it's going to travel contralaterally. So ipsi means the same side, identical side. So ipsi start with I, identical start with I. So they travel the same side. Contralaterally, which is here, means the signal travel on the other side of the nerve cord. And there's another way they may use, which is bilaterally. So in this model, between A4 and A5 is still ipsilaterally because signal travel the same side. And then after A4 is bilaterally because some of the nerve will decussate, will cross A4 ganglion and reach the other side of the nerve cord. So on both sides of the nerve cord, you have some nerve fibers that's generated from this end and go over here, and you have some signals that travel directly from this side. So in this situation, between A4 and A1 ganglion, the signal travels bilaterally. So which is the case, we don't know. Or even the decusating point, which ganglion the nerve cord is crossing, we don't know either. So we're going to design experiment and to see which one is the right model in this lab. And if you remember, this is the closer look of the circus. There is some hairs, and the bottom hairs, they have mechanoreceptors. You're going to poke them, so the signal will be generated on their circus, which is here. So the experiment designs, and because it's pretty complicated surgery, so we won't be able to finish all this experiment within one group. So we're going to form a super group, which have 3 groups, and each group will test different segment of the nerve cord. So group number 1 will test between the 2nd and 3rd ganglion, and the other group tests 3rd and 4th ganglion, and then the last group tests between the 4th and 5th ganglion. Of course, we have to isolate these ganglions before we testing them. In this lab, we're not going to test between the 1st and 2nd ganglion because these two ganglions are very close to each other. It's hard to isolate them. Okay, so expected result. Let's say if this is how signals travels on the nerve cord on a cockroaches, what is these 3 groups are going to observe? So for group number 1, their recording site is on this red nerve. Alright, this is their recording site. They only connect this one nerve cord to the power lab. And if they poke the same side of the third side of the recording nerve, you are going to receive some signal. If you poke the other side, they won't see any signal. For group number 2, it's going to be the similar result, right? You poke the same side, you see signal, poke the other side, don't see signal. And for the group number 3, the same. For if all of the 3 groups sees the same result, you're poking the same side, you see signal, you poke the other side, you don't see signal, we can conclude between A5 and A2 ganglions, the signal will travel ipsilaterally. If this is the situation, this group and this group will receive signal from the other side of circuit stimulus. However, they won't be able to receive any signal if they poke the same side circuits. For group number 3, they supposed to see some signal. They poke the same side circuits, but not the other side circuits. Okay, so this is the expected result for this model. And if the signal travel like this, for these 2 groups, they're supposed to receive signals. Doesn't matter which circuits they are stimulating, they always receive signals because signal travels bilaterally between A4 and A1, right? For this group, they supposed to see some signals from the same side circuits, but not the other side circuit stimulus. Okay, so this is the expected result. And we have 2 more videos. One is microsurgery. It is basically the recording of me doing a surgery again. Very similar as last week. The only thing is I only hook up one set of nerve cords for this week experiment. And all the power lab was set up exactly the same as last week. Experimental recording video, that's a videotape of me recording signals from the nerve cord between the second and third ganglia only. I didn't videotape the signal recorded between the third and fourth or the fourth and fifth ganglia, but I did finish the experiment. All the signals are saved in the file module 5B recording demo. You will need this file to finish your post lab. Okay, that's the lecture part of this week, and good luck.